Alright, so today's lesson is on graphing linear equations and inequalities, and this is primarily a review for you guys. So let's get started. So first of all, we're going to graph using the slope and the intercept of our equation or inequality. Remember that equations are best to be graphed in the y equals mx plus b. Remember, m is the slope and b is the y-intercept, and that's where we always begin. So I have two equations here. My first one I'm going to graph in a blue. It is y equals 2/3 x minus 5. So remember, b is where I begin, so I'm going to start at -5. Alright. And then from there, I'm going to count my slope of 2/3. That means I go up 2 and over 3. Plot a point, and I can even do it again. Up 2, over 3. And then I want this to be in blue, this line in blue, just so it stands out. Make sure to put arrows on the end of that. Alright. Then I'll graph my second equation, y equals -2x plus 3. I'm going to start at the positive 3. And then my slope is -2. That's the same thing as -2 over 1. So I'm going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1. And I'm going to graph this one in red, just so you can see it. Okay? And so the solution to this system, because it's two equations, the solution, or the place where these two lines intersect, is at the point 3, -3. Okay? Alright, let's try another one. Inequalities, we're going to graph using the slope and the intercept as well. To graph an inequality, we graph the boundary line. If we have the symbol less than or greater than, our line is dashed. And if we use the symbol less than equal to or greater than equal to, our line is solid, meaning that all of the points on the line are included in the solution set. And then remember, we select a test point, not on the line, and check to see if it makes it true. So here we're going to graph this inequality system. My first one is y is less than 2/3 x minus 5. You might think that looks familiar, just like the last equation. I just changed the symbol. So I'm going to start right here at -5. And then I have a slope of 2/3. Up 2 over 3, up 2 over 3. And I'm just going to look back at this and double check. And I see that I'm going to use a solid line. So I'm going to graph this with a solid line. Color blue. And then I'm going to select a point that is not on the line. So I'm going to select the point 0, 0. It's not on the line. And I need to see if it makes this inequality true. So is 0 less than or equal to -5? Well, 0 is greater than -5. So I'm actually going to shade on this side of my boundary line. I'm going to shade opposite of my test point because my test point does not make it true. Okay? Now I'm going to choose the inequality y is greater than -2x plus 3. So when I graph that, I'm going to start at the plus 3, positive 3, and then my slope is -2, down 1, 2, over 1, down 1, 2, over 1. And I'm going to look back at this and I see that it is a dashed line. Okay. And then again, I'm going to choose a test point that is not on the line. The point 0, 0 works perfectly for this. And I'm going to plug that back into my inequality. Is 0 greater than 3? Well, 0 is not greater than 3. 0 is actually less than 3. So I'm not going to shade on this side. Instead, I'm going to shade on this side. Now, if this were a system, you would see that these two inequalities have a solution set that overlaps right here. This is the overlapping place, or the portion of the solution that makes both inequalities true. So this would actually be the solution set. Okay? All right. Graphing using intercepts. This is the cover-up method, and we needed to talk about this because so many of you had forgotten. So graphing using the intercepts, we just call it the cover-up method, so we can actually start with the ordered pair something and 0 and something. So what this means is that I'm going to cover up the y term. I'm going to take my hand and just cover up the y term. 3x times something equals negative 12. Well, 3x times 3 times a negative 4 equals a negative 12. So this is the ordered pair negative 4, 0. And then I'm going to look here. I'm going to cover up the x term. Negative 4 times what equals negative 12? Negative 4 times 3. And I can actually just plot those 2 points. I'm going to come over here to my number line. Negative 4, 0, and 0, 3. This is an equation, so I'm actually just going to graph my lines. Okay, let's do that second one. All right, here I have cover-up method again. I'm going to write my 2 ordered pairs. The first thing I'm going to do is cover up the y term. I'm going to let y equal 0, and when y is 0, 2 times what? Negative 2 times what equals 10? Negative 2 times negative 5. Yeah. So negative 2 times negative 5 equals 10. That's true. So now I'm going to cover up the x term, or I'm going to let x equal 0. So I have 5 times what equals 10? Well, 5 times 2 equals 10. So now I have these 2 ordered pairs that I can graph. So I'm going to go to my x-axis at negative 5. Then I'm going to go to my y-axis at 2. And I'm going to graph those 2. Okay? So that is how you graph an equation using intercepts. Remember, intercepts is just like the cover-up method. And then we'll get you going. Here's something to remember. Solving systems of equations. Remember that the solution to the system makes all the equations in the system true. If you get a solution to a system of equations, check it. Plug it back in and check and see if it works. Infinitely many solutions have the same line. They're the equation of the same line. If you have one solution, that means that the lines intersect. And if you have no solutions for a system, that means that the lines are parallel. The lines are parallel. With inequalities, the solutions to the system make all of the inequalities true. And the solution to the system is the region of the overlap. The solution for your inequality is the region of the overlap. Okay? So we're going to graph one system of equation and write down the solution, and then we'll graph one more system of inequality, and I'll get you started on your practice. We can choose either method, and you see that I have the equation y equals 4x minus 1. So this, I'm going to use the slope-intercept form to graph. And then this method, I'm actually going to use the cover-up method, or the intercepts. Okay? So y equals 4x minus 1. Well, I know that my slope is 4, and my intercept is negative 1. I'm going to go ahead and graph those. Negative 1, a slope of 4, that means I count up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Solid line, connect those points. So this is the equation y equals 4x minus 1. All right? Now, let's look at this equation. Again, I can use the cover-up method. So I'm going to let y equal 0, and then I'm going to let x equal 0. When I let y equal 0, I see that x has to be 6. And when I let x equal 0, I see that y must be negative 3. So I'm going to plot those points. 6, 0, and 0, negative 3. This is also a solid line. All right. So the point of intersection would be right about here. It's not an exact point. I don't have an exact point for you, but at least I've identified your intersection. So this would be the solution, right? The intersection is the solution to this system. Okay? And now we're going to do this same process using the inequalities. Again, I'm going to graph this using the slope-intercept form. My intercept is -1. I have a slope of 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Check and see, since this is an inequality, do I have a solid line or a dashed line? Greater than tells me I need to have a dashed line. There you go. I'm going to pick the point 0, 0. Is 0 greater than -1? It is, so I'm going to shade on this side of my boundary line. I'm going to shade on this side. I'm going to try and get as close as possible so you can actually identify the overlap. Okay. There we go. And I'm going to extend that just a bit for you. Okay. So the next equation, using the cover-up, I have the ordered pairs. So when I let y equal 0, I know that x is 6. And when I let x equal 0, I know that y is -3. So I'm going to go to the point 6, 0, and 0, -3. And this is also going to be a dashed line. Okay. So this is my boundary for my first line that was all blue. And then for the red, is 0 plus 0 less than -12? No, 0 is greater than -12. So all of this region would be the solution to this inequality. But you see, this is actually the overlap region. The overlap region is just this little piece right here. That is the overlap. Okay? All right, that's all I have for you. So you have a little bit of practice. I'd like you to practice for about 10 or 15 minutes, and then you have a check for understanding in my big campus. Good luck.